Hello everyone, welcome back. Let me introduce you to our next speaker now. He's Martin Beeby. He is currently working as a principal software engineer with AWS since last couple of years. He's been developing since he was 16. He's probably done all of the different languages, but his main specialty is .NET. He has worked for Microsoft before for probably about 7 years and 11 months, nearly 8 years. He has worked for Oracle as a director of evangelist, and he has been speaking to different events, different meetups, not in the UK, not only in the UK, but all around the world. He has spoken to about 200 events so far, or over 200, and we are very fortunate enough to have him tonight as a speaker. He's been speaking in NDC London conference as well this week. So can we please give a massive round of applause to Martin.
Thank you very much. Thank you very much. So I've been to pretty much every .NET user group or meetup in this country, and I used to work down the road, but I don't think I've ever been to .NET Reading. So this is a first for me. I know, I don't think I have. I mean, I've done a lot of .NET meetups. So I'm going to be talking about building real-time applications in .NET. I got into this in a really big way quite a long time ago when SignalR first came out. And basically it's about building real-time applications, web applications, primarily, that's at least my experience, and all the different ways of doing it. Now, I actually got asked to speak here about a week ago, and they also told me that I wasn't, or a couple of weeks ago, and they told me I wasn't allowed to do my actual NDC talk. I didn't really have enough time to sort of prepare something completely different. So there is some crossover between what my NDC talk is and this talk, but this is meant to be like a background to what I actually will show at the NDC talk. So it's all the different ways that you can build real-time applications in .NET that I've done, and hopefully it should be fun. So we're going to be looking at what real-time applications are and what I mean by that term, how we can build them without serverless technologies, how we can build them using serverless technologies, how it relates to Blazor, and then if we have time, which we might not, some of the experiments that I'm interested in doing with GraphQL to do real-time stuff as well, because it's a really interesting work which happens in the JavaScript world in GraphQL, which I'd love to port into the .NET world, because I think that GraphQL has lots of benefits for .NET developers, but it's not really used as a back-end at all in our ecosystem. This is possibly the most important picture in my entire slide deck for me. Is there anyone which has got a phone camera which would take a picture of me in front of this slide? The reason it's important for me is because this is my inception slide, and it's a thing that I started doing about 1.5 years ago, and it's me standing in front of a slide, and you'll see the other picture is me standing in front of a slide, and then it's me standing in front of a slide, me standing in front of a slide. If anyone gets a picture of that, oh, you got good, but you're not going to be able to tweet from that. Like there's going to be a delay off that. You can tweet it to the Beebs on Twitter. I mean, you could just follow the Beebs on Twitter if you want. I mean, that's up to you. But you can do that, and then I'll have the next talk that I give will be this one of those pictures I'll choose, and then I'll try and keep a chain of continuous Inception pictures. I'm currently at level 41 of Inception, so there's 41 levels, and I have a team, I kid you not, in demo engineering at AWS who are currently working on a demo for me that when someone tweets that with a new picture, it will add it to my deck and then generate a video which flies through. And I can't believe they agreed. I pitched the idea like, I can't be bothered to do this, but you guys would be great at doing it. And they're going to do that for me. So hopefully by in a couple of, next time you see me talk somewhere, that will be like interactive as well. Possibly using real time, which is the thing which I'll be talking about today. So I'm a software developer. I have been a software developer since I was 16 years old. I've done lots of different languages in my time, but I keep coming back to .NET. I got my big break, I guess, in software development when I got hired by Microsoft in around 2009, and I started doing interesting stuff with around .NET, but they also got me doing crazy stuff with PHP and Node and Go and various other languages. But I was kind of always in the .NET ecosystem and always doing .NET stuff. And then I went to Oracle in 2017 for a little diversion in my career, good money. And they kind of, I went into a different world where I was talking about a lot more Kubernetes. I was talking about lots of different Java frameworks, which I'd not really used very much before. And I had a whole seen a whole different industry. And then AWS phoned me up and said, "Hey Martin, we used to like the stuff that you did on .NET. Would you like to come to AWS and talk about .NET at AWS?" And I was really surprised because I had no idea that AWS did much with .NET. I didn't understand AWS at all. I never used it previously very much. So that's what I do now, is that I go to .NET places and I do .NET events and stuff, and I do talks on .NET on AWS. I'm not going to be giving that talk, but you will definitely see me in the future. I'm sure if you go to enough events, you'll find me there talking about AWS. Tonight, obviously, I'm going to be showing a lot of stuff which is AWS specific, and there are, but hopefully some of it should be relatable to other cloud vendors as well. And so yeah, I've been a software developer for 21 years now actually, and I work at Amazon Web Services now. So I'm going to be talking a bit about real-time. I think I'm fascinated with this world of application development because it kind of marries the two things that I really like, which is I really like front-end stuff, like JavaScripty stuff, in-browser technologies. I like WebAssembly, I like WebSockets, I like those sorts of things. And I also really like back-end technologies as well. And SignalR, when it came out in the .NET world in sort of 2011, that was the first time I was sort of aware of it, it kind of opened up this opportunity of marrying these two together in a more interesting way, like the server and the back-end, how they can communicate both ways. How can they, not just the client browser making a request from the server, but the server sending information directly to the client as well. So I got into this concept of real time, and you see it exploding in that when we used to use the web, it was very much you'd go to a web page and you'd read some information. And then websites became more, DHTML came about and Ajax, and we started getting more interactivity. But the way the communication platform was working was it's fundamentally HTTP. And what's happened is, over the last 10 or so years, we've started to see like notifications and real time are just appearing in applications all the time, to the point where you don't even notice that that's what they're doing or that that's where it is. So, for example, if you're using a messaging app, there's many different ways that they're doing it, but there's lots of real-time activities happening in that messaging app. Not only is the messages which are being sent obviously happening in real time, when someone sends it, it's getting pushed down to your phone. The fact that when they read that message, it's being monitored if they're reading it, and then that's sending a signal to your phone to give you a UI to tell you that they've read it. So, like, all these different interactions which are happening all in different applications in different places are all getting merged into our user experience. And you might not always notice it, but it happens all the time in banking applications, with banking alerts and news stories on websites when they've got breaking news. That ability to push information to a browser or push information to a mobile phone, that's kind of what I'm talking about when I'm talking about real time. Stuff happening in the world affecting your application without you making requests to websites, without you going to specific places, stuff coming to you. And I've built SignalR applications and WebSocket applications and real-time applications in all these sorts of categories. I worked on a few years back, I worked on a multiplayer game. It was a browser-based multiplayer game which used WebSockets really intensively to communicate the different positions of players which were collaboratively working in this game. And so we did all of that in real time. So as one player moved to a different place or their health changed, that would be updated with the other players. The canonical example in any real-time application is always a chat application, creating a chat application, because it's simple to do, it's easy to understand, and it's using this concept of messages being sent back and forth between server and client. Shared whiteboards, if you open up Skype, and you open up a whiteboard, and then you're drawing on that whiteboard. As you're drawing, it's getting relayed to all of the different users in that room. Well, that's all happening with real time. It's real time updates as to how that person is adding the information. It's getting broadcast continuously to all the people in that room. AR and VR experiences. Not long ago I was working on HoloLens, and a lot of the HoloLens experience is figuring out where the other people in the room are when you're collaboratively working together. So updating that stuff in real time as to where they are, what their position is, and how you interact with them is really important. Document collaboration, if you've ever used Google Docs and worked on a document with another person in a different planet, and they're typing and you're typing on a document at the same time, that's become a really common way of working collaboratively. Or if you're in Visual Studio and you're using LiveShare and you're you're co-authoring together. It wasn't that long ago that those sorts of collaborative experiences were impossible or really, really difficult. And now it's become the case that a lot of implementation of real-time is actually not that hard, and even scaling it now is not that hard. It's certainly not as hard as it used to be. And so I'm going to be talking about these sorts of things and how you can go around building these sorts of applications. There's another example on hotel website where you'll be looking at a particular hotel and all of a sudden something will pop up saying this hotel has just been booked. Someone's just been booked at. Now that could be real time. It could also just be some JavaScript on a timer, just saying it's just been booked. Book it now. Make sure you book this place. But however you do it, I think that's technically a legal dark pattern now, right?
Yeah, they've been called up by that.
Yeah, I know. Fantastic engineering. I don't know why, but the idea is interesting, right? Like the idea that you're looking at a static web page and they are pushing information to you to encourage the sales behavior. That's a really good use case, even though it's technically illegal. If you're collaborating on documents, we use this thing called Quip. Quip. But I think it's by Salesforce. We use it in AWS for a lot of our document collaboration. And if you're sharing a document on Quip and someone's viewing it, just looking at it, it just shows you who's viewing that document. So you can see when you send an email out with the new fancy plan for that year, and then no one actually views it. Or I often will sit in my document and see there's one person checks in and then immediately checks out of my document, and it's kind of interesting. Very rarely do you get a lot of people viewing those things, unless, like you say, I've just disclosed the salaries in this document by accident. Please don't go look there. And then you'll get then everybody logs on and views it. Don't do it. Or send an email then delete the email. That's a good way to get people to read an email. Anyway, please don't open. But that kind of the idea that they're viewing it in their browsers on their mobile phone applications, when they open that document, it sends a signal somewhere to a server. That server then relays it back to you to say that they're viewing. And that whole architecture is complicated, difficult, but it's becoming a lot easier, and we can start creating these really useful user experiences like this. Or when someone's typing, this is also another thing. In the chat window on Quip, as they're typing about comments, it will just come up with this one. This is possibly the most annoying UI interaction. They call it indeterminate waiting. When it doesn't give you how long it's going to take, but someone is typing. This happens on WhatsApp as well, and you're just like, what are they going to type? Oh, they stopped typing. Oh, they're typing again. A badly implemented version of that is the worst thing in the world, because they're actually not even there. They're not typing for whatever reason. There's something's triggering it and then stopping it. But that is all real time, right? But basically they've captured a keystroke as they were typing on their browser. That keystroke's been sent. They're typing. Then it goes to a system. The system then relays it to you, and then it ultimately ends up inside of your UI saying that someone is typing. Now, traditionally, the way that this has been done, there's been a few different browser technologies and mobile phone technologies to do this. Obviously, in mobile, we have another mechanism of getting back to the phone, which is like notifications, push notifications, which is different. But fundamentally, that's an operating system level kind of equivalent to some of this stuff. But in browsers, at least, where I was doing this stuff originally, these were our techniques that we had in our arsenal. The first one, which was around 2003, Ajax time, a thing called long polling. Now, of course, you could just, by the way, to do real time, you could, if you were thinking about how you might architect something like this, you could just put a loop in a JavaScript type loop, and then call a URL every 10 seconds and see if there's new information. I mean, that would be a terrible way of doing real time, but that's often the way that people start when they're doing real time. They'll just poll a server. Now the problem is that what you're effectively doing is designing your own denial of service attack on your own service, right? Because enough users, you'll start getting enough people calling into and denying your service. So to kind of mitigate that, they thought, well, what about this concept of long polling? And long polling is just a little hack, and all it does is when the JavaScript makes a request to the server, instead of immediately responding, as HTTP does usually, it holds on to the request and waits. And it can wait for like as long as the browser can handle waiting, and as long as the server can hold the connection. And when some new information comes up, which the user might be interested in, it will take that information, collapse it back, and pass it back as a request. So basically, you've got the server holding on to requests for a long period of time, and then passing stuff back. And long polling was the only way for a long time of doing real time on the web. That's the way that you did it. There's obvious problems with it. If you're holding on to HTTP requests as they come in, you're using massive amounts of server resources. It costs, it's memory intensive, it's CPU intensive, it's really not efficient at all. And you can only handle like 200, like our average server can only handle 100 people doing that. So it's not something you can really easily scale with long polling unless you've got a bank of thousands of servers. We don't really see that one being used very much anymore, with one notable exception, which might be the largest use case on the planet, which is Facebook Messenger. If you use Facebook Messenger in the browser, they have really cleverly engineered a long polling solution. I don't know if it's actually still in production, but it was for a long, long time. They were using long polling to do their real time. So when anyone did that typing or messaged you, it was using long polling to achieve that. And they must have had some really smart servers which were designed specifically for that kind of transport to do that. But they were doing that because they wanted it to be on every browser possible in every way that they were able to support Messenger. Forever Frames was another hacky technique using iframes and basically passing requests through a frame in the background, which gave you better another sort of way of doing effectively long polling, but a slightly different way, a slightly more effective way. Very rarely used at all nowadays. Server-sent events. Basically, the browser manufacturers all sat down and said, this is terrible. We need a better way of doing this. What we need is the ability for the server to speak to the browser. Because that's the problem, right? You can request from it as a browser, you can request stuff and get pages back, but the server can never arbitrarily call you. You have to always call him first. And so it's always like that client, the request coming in, the server, that always has to take that response and it's basically responding to requests that are coming in from whomever's using the service. Now, server-sent events was like, well, the committees sat down and they said, well, how about we think about architecting a way that the server could speak directly to connected clients. And so they invented SSE, you might have hear it being referred to, but it's still a one-way communication channel. Basically, the server has now got a way of sending a message to the client, and the client's still got a way of sending a message to the server, but every time a message sent, we need to create a connection between the two. So it's like very intensive. It's good, though, for things like broadcasting a breaking news event, because you only really want to send one message to the clients which are connected to you. You don't need to open up a duplex communication channel between the two. So actually, and there's loads of scenarios where server-sent events would be really useful. I've never implemented server-sent events other than in a demo, but I'm sure that there's loads of really good use cases for it. And then after a while, they said, actually, do you know what? What we need is like a socket, like a networking socket, but we need that for the web. And they sat down as a committee, the people which decide the internet. I don't know who that is. Tim Berners-Lee, sitting there with his hat on, and then a few other. No, the committees at the JavaScript. I do genuinely know the people which do that. They sit for about 20 years and they decide on new standards for the internet and what they can do. And they came up with this concept of WebSockets and said, the standards committees said, let's create something which works over HTTP, works over port 80, or port 443, and can create a duplex socket between the client and the server, so information can pass both ways. So there'll be some kind of negotiation to start up the communication channel, and then we can pass messages back and forth between client and server. That's what a WebSocket is effectively. The negotiation works like this. You have an app, could be a browser, could be a mobile phone, could be a console application with WebSocket, with capabilities of connecting to a WebSocket, which practically every programming language is capable of. We create a new WebSocket class, and we call to a server. Now, the first thing that's going to happen in the protocol is that the app's going to ask the server, do you support WebSockets? Because in a original days of WebSocket support, you needed not only the apps to support WebSockets, the browsers or the mobile phone or whatever, you also needed the server to be able to communicate with this new protocol. And it used to be the case that servers did not know how to deal with WebSockets. So you'd often get like a response back from the server saying, I've got no idea what a WebSocket is. And so then you'd have to fall back to long polling or fall back to another technique. And if you use SignalR, if you've ever used SignalR in .NET, which we'll look at in a little moment, SignalR will basically do this negotiation and basically find the thing that both the browser and the server can handle. So if it calls the server and the server says it doesn't support WebSockets, then it will try to do server-sent events. If the browser doesn't support server-sent events, then it will try to do forever frames. If forever frames doesn't work, then it will fall back to long polling. That's how SignalR works. It's not just a WebSocket communication thing. So the app, the client, asks the server, do I do WebSockets to you? And then the server responds, of course, it's 2020, of course I do. Then they can create a duplex communication channel between the two of them, which means that they can communicate. And what's cool about a WebSocket is once it's established, they do it, the handshake, that negotiation happens over HTTP, but then they create this socket, which is then any message passed between them doesn't have all of the headers, doesn't have all of the complex jargon that goes along with a HTTP message. It just is the message. So it makes it really efficient to pass information. You can pass JSON objects, you can even pass binary across a socket. And it means that it really becomes very efficient to pass information between a client and server. So it's used in lots of different web frameworks. Yeah, sorry, question?
Is that still happening over port 80? Don't shift to another port?
Yeah, 443. Yeah, it supports the secure socket. So if you ever see a WebSocket called WS, that's a WebSocket, port 80. If you see WSS, that's or WWS, or WWF. WS, I can't think of. Yes, it's not 2 letters, 3. Then that's a secure port. It will go over 443. So it's a secure socket, and the technology is exactly the same in that it's a secure socket. So the communication between the two is is encrypted. Now, once it's established, you can pass messages back and forth, and so lots of applications are not just using it for doing real-time notification stuff. They're actually using it as a mechanism to have a more lower latency transmission between the client and the server. And things like Blazor with the hosting model for the server hosting model actually uses WebSockets to communicate partial rendering of the pages in a really interesting sort of crazy architecture pattern that they use. And so it's interesting that this is still pretty much how real-time works on the web, and most real-time applications you see will be using some form of WebSocket to do stuff. Even GraphQL that I mentioned earlier, that has a really cool real-time API. It's all under the hood using WebSockets. There's nothing fancy or new in this world. It's still all WebSockets. So the first thing I used was SignalR. SignalR is a great little framework for getting started with real-time applications. And if you've not seen it before, it's been around since fullfat.net. It's a really popular real-time framework. I believe it was built by David Fowler. Yeah, good. I always call him Damien Fowler by accident. It's David Fowler, which is actually SignalR was the whole reason I started following David, and I'm glad for it forever, just for that one thing. He's a great person, great engineer to follow on Twitter. But this is the ability to do. It basically took the complexity of doing WebSockets and just made it simpler. Because pretty much every other you have, even in Node.js, you have like Socket.io. It's way more. I find it more complicated than the SignalR to implement. SignalR takes a few minutes to implement in an existing MVC application, and then they ported a version for .NET Core. The .NET Core version was a long time coming. They were working a lot on I guess David and co were working a lot on .NET Core, so it took a long time, but it's now there and stable, and you can use it. And it also forms the basis of a lot of the stuff in Blazor, so it's quite cool from that point of view. And it still has this kind of this degrading ability as well. Less so, I think, in the .NET Core SignalR version, but in the full fat version, in full framework version, it supports WebSockets, server-sent events, long polling, and degrades based upon whatever the client works on. So it's a really good little library for building stuff. when I joined Amazon, I was thinking, well, how do I get a SignalR application running on AWS? It was one of the first things that I did, actually. And there is a service called Elastic Beanstalk AWS. It's like a pretty old service now. It's like one of the original PaaS services for clouds. It's constantly being redeveloped, and we have like loads of new features in Elastic Beanstalk. For example, we just added Windows.NET 3.1 Core 3.1 support to Elastic Beanstalk. It's constantly being updated with new versions. You can use it for PHP applications, Node applications, and all sorts of things. And the idea is you give the code, you build your application, you give the code to this service, then the service deploys the code to a cluster of machines. And it has responsibility for making sure that those machines stay online, and it will redeploy the application if any of them fail. It will rebuild them if machines fail. So it's like basically a PaaS service before Docker, like before that was a thing. It's a bit like Azure Web Apps service, I guess, if it's a similar sort of concept. You have a load balancer in front of it, and then you have your machines. So the simple thing is you just go into Visual Studio 2019, you right-click your project. If you have Amazon tools installed in Visual Studio, you right-click, publish to Elastic Beanstalk, wraps up the application, it publishes the application. Then I discovered there were two things that I needed to modify. Both can be done in configuration. One is the Elastic Load Balancer. If you're just talking to one server, nothing you really need to do. If you've got more than one server, like have 6 different servers, and you're using SignalR, the SignalR connection needs to connect back to the same machine that it was talking to or established the WebSocket with. So you have to just switch on sticky sessions on the load balancer so that it goes that once you're connected to the network or to the server, you go back to the same server again and again. Otherwise, you have like an unstable socket connection because it will try to reestablish through the load balancer and it will connect to a different server which has never seen your WebSocket before. And so that was one thing I had to do. The other thing was in Elastic Beanstalk, you actually have its physical machines that it creates, new instances it's creating for you. And you have to, on IIS, you have to enable WebSockets. It's not enabled by default. So there's a PowerShell script that's part of the repository that I've got there, which runs basically every time it deploys the application. There's this entry point that you can run arbitrary bash on Linux machines or arbitrary PowerShell. And in there, you just basically enable WebSockets. And I have a little piece of code in. That's the only other thing I added to my existing SignalR application. And then boom, it kind of worked. It just started working. So to show you what that little real-time application is, let's go to here. So if anyone's got a phone, I don't know, you've got a phone? Oh, a few people followed me. That's good. We should be able to just go voting.thebeebs. Okay. And if it's worked to anyone, I don't know if anyone, you should be seeing like a grey, please wait. Yes, it works for you. And you, and you. Good. This is basically the most production my code's ever seen for like 4 years now. Please wait. So what's happening is I've got a little .NET Core application. It's using SignalR in the background. I'm using Reveal.js to build a slide deck. What else am I doing which is fancy? Nothing. You click on that, and you should then see what drink, coffee or beer. Okay. Now, so there's a web signal, there's a socket signal connection happened when I changed the slide. So that slide sent a signal to everyone's phone saying new question. You all got a new question, then you pressed one of the buttons, and then that button then sent all of those different things sent a thing to my system to then like increment the vote count. So we've got like some communications going on and back and forth. And then hopefully if I click to the next one, tabs or spaces, you should be promoted to another one, tabs or spaces. Only pick the big issues. Brexit or not Brexit next. No. I disabled one of those options, so it was no.
BSD, not tabs.
So you see that it's a really straightforward little example application. What happens in the background if I can see? Let's see if I go to developer tools, and I just refresh that page and go here and go to network. there should be somewhere on here a negotiate, and that negotiate is the thing I was talking about when the connection, the WebSocket negotiation happens, and it happens over a URL, and it's just a HTTP request which goes in, and it tells me what the available transports are. It says that there's WebSockets, server-sent events, long polling are available. It assigns a connection ID to my particular user, and then it establishes this, which is a WebSocket. And in a browser, this is what a WebSocket looks like. So you'll see as people vote for different things, as I press buttons on my machine, on my phone even, as I press that there, I got a response coming back. It's basically like a little message which comes in the WebSocket. So a WebSocket just looks like this. It looks like a collection of messages which are received. And these messages are arbitrary. They're just JSON at the moment, but they could be, you could pass any sort of information directly through them. But they're kind of, that's how this kind of little system fits together. Now it's quite straightforward how you code something like this. Let me just not show you how much I'm going to go into this, but I'll just show you briefly, like roughly, what the important parts of a Signaler application are. So it's kind of a regular .NET application. I have a hub. Oh, of course, this is a .NET Core application, so there's some stuff going on in startup.cs. app.use Signaler. And I'm basically saying there's a voting hub URL, like there's a route which is like my Signaler route, and that's the thing which people are going to be able to negotiate with. That's going to be the endpoint which people call. So it adds that. Signaler sort of gets set up in the background. I do that before MVC. What else in this application have I got installed? I've got a thing called X-Ray. This has got nothing to do with Signaler. It's just a tracing tool that AWS use. So we have an SDK for pretty much every language. We've got one for .NET as well. And X-Ray kind of like is a way to instrument my application to find out where the requests are coming in my application, how long database requests are taking, how long stuff is going. If there's any exceptions which are thrown, it does all the tracing and stuff. And that reports to like a little daemon on the Elastic Beans, the servers which run, and then that eventually gets polled to a service, and then it displays in a dashboard. Now, so Signaler is pointing over to this thing called Voting Hub, which is a solid class called Voting Hub. So if I go into the hub, we have this thing called Voting Hub. And it's a bit messy. My code, which I've written here, is meant to be for people to view it and understand it rather than being refactored at all. So it's a little bit embarrassing in many ways. But you'll see that there's a few methods, one like set question. So set question is when in my slides, I click and say next slide, that effectively sets the question, what the current question is. It not only sends the question to all of you people, I store it in a little database. And I store it in a database system called DynamoDB. It's a NoSQL database store in AWS. That's how you store it in the database. It's basically just doing a put operation onto that NoSQL database. I've got a function called getCurrentQuestion, which gets the current question. I've got a thing called addResponse. Every time you vote, it adds a response. It records that information. And I have this onConnected sync. Ooh, let's just... so we have these sort of C# methods. One of them, like when I send a question or when I change the question, it calls this one, which is group. Set the question, then tell all of the connected clients what the new question is. And so to contact all of the clients which are connected, I just say clients.all, and Signaler takes control of figuring out how to communicate back to you through WebSockets. All I do is like this one line, clients.all, send this message to all the clients which are connected, and it will send it all. I can send clients.group, I can send it to like a group specifically. And so we have this sort of like these C# functionalities which just call these methods. And then in JavaScript, on the client side, I have, let's see if I have it on, will be on the management page. This is my application. Oh, I want to go on index actually. This is the application that you guys use. So it says please wait, and then I've got a little script, a JavaScript thing, which is a Vue.js application. And I think somewhere in here, let's see, in my scripts in www root, that's it, JS site. I have a new Vue.js application. It's still like a data model. I've done this really lazily, like I've got two options, like 1 or 2. So my application doesn't support any more than 2 options for voting, which is not great. I could use it like a US presidential election, but I couldn't use it anywhere else. So you've got like a, when the Signal application starts up, what we do is we start and make a connection. When the application is created, we create a brand new object called a connection, a new Signal connection from JavaScript. And then once that connection's established, then I can just say, this dot connection on, so when a message is sent, that will event, and then I've got an ability to sort of send stuff as well to it. So this dot connection dot invoke, and what's interesting about the way SignalR works is that actually invokes the C# function called send response. So there's like over WebSockets, they're basically passing a message which is crafted in a certain way that the C# stuff will pick that up, then reflect over it, then execute C#. So it's really interesting, like you don't know where you belong. Am I in C# or JavaScript? And this stuff's really fascinating to start work with and do real-time stuff with. But it is also like it can be very confusing where you are. You need to know a lot about JavaScript really though to do this, the passing of information around. And it's a whole sort of nightmare. Now the problem, it's good and it's been a fascinating way of doing stuff. But I guess
That's similar. What library is that in your JavaScript?
so the JavaScript's actually generated. The JavaScript library is a SignalR JavaScript library. It's actually generated by the C# object. So when you install the NuGet package, you can just reference a JavaScript library which is generated by the hub, by the SignalR NuGet package. Okay. And then I'm just using, you have to connect to it via JavaScript to connect to the SignalR hub to send messages. And then you have this hub which is basically listening for the messages and doing all the WebSocket stuff and setting up the WebSocket server. But the concept is you have to kind of do this JavaScripty dance between JavaScript and C#. And it's cool, but it's not without its problems. And one of the problems is, let's just say we've got this voting mechanism and we have a load balancer with more than one machine. All of a sudden stuff gets more complicated because when we're just using one machine, my system's connecting to one application and it's dead easy and it's dead simple how it works. But if we add more machines, all of a sudden, like the information, the message which gets sent between the clients and the servers now has to be duplicated across all the different servers. Say we're in a chat room, for example, and I connect into the chat room, and I send a message to a server, and someone else on my server sends a message. Well, I'll see their message. But if someone connects to another server and they send a message to that server, well, they'll only see messages from that people connected to that server. So you have this problem where the client and the server communication works, but server-to-server communication no longer works. So in real-time worlds, what we do is when we have a backend with more than one server, we need a backplane, something which passes the messages between the different servers. In SignalR, you use Redis. Redis is a caching service. I'm using Amazon Elasticache for Redis, which is basically a managed Redis service. And we can create that. And I think we just need to add this one line of code in .NET Core. So where we would ordinarily just put services.add SignalR, we now add .add stack exchange Redis, and then put a connection to our Redis server. And then there's some configurations that we can add, like what channel we're going to be working on, because we might be using a Redis backplane for more than one application. So we'll create a channel called My Application. And now all of the SignalR systems which are using that same channel the messages some magically just get passed between the servers, and before you know it, you can just basically assume that messages are getting passed to all of the different servers. And so it's the way we scale something like Signal R with a backplane in Redis. Now all of a sudden though, this is getting complicated and it's getting expensive because now I've got like a load balancer, I've got 2, maybe 3 machines, and I need more machines because let's say I'm using WebSockets. Well, a single reasonable sized Windows instance will only be able to handle 1,000 concurrent connections on a WebSocket, maybe. I've never really done the testing, I don't know it's about that. So if I want to handle 6,000 concurrent users, I need 6 servers. If I want to handle 1 million concurrent users, I need a lot of tin, a lot of instances. I need to probably to do whatever Facebook did, and then completely change the architecture. But it becomes more complicated about how you start doing this. And then Redis isn't cheap either. Like Elasticache is not inexpensive as a service, and especially if you've got a big enough cluster, it starts getting expensive. So this starts becoming quite an expensive application to run. So last year, 2018, I went for the first time to a thing called AWS reInvent, which is our big AWS conference. 65,000 people in Las Vegas, and they basically for a week talk about over 3,000 sessions about AWS. And I went to one session from the API Gateway team, and they'd added a new feature to this thing called API Gateway in AWS called WebSocket support. And I thought, well, that sounds cool. And they showed a demo which just made me think, I should do something with this. And this is kind of I've been working on this concept for a relatively long time now, and it's just starting to come to fruition about what it is. But basically, the concept is this. It's a serverless model for dealing with WebSockets. So let's instead of having your server or your application handle the WebSocket connections, we have this service called Amazon API Gateway, and it has a WebSockets API. You create this WebSockets API. It's a piece of stuff that you create. Your IoT device, your mobile application, your chat application, your dashboard, whatever application you developed, connects up to the API Gateway WebSockets API. And this manages all the WebSockets. So it's dealing with the servers, it's doing whatever it's doing with the backplane, it's doing all of that stuff. And then someone connects to that, and they have a stateful connection with this piece of infrastructure, which is managed. It's nothing to do with your application. And what we have on the other side is our application. Now, this application could be Lambda, which is a serverless application. It could be containers. It could be an MVC web API hosted on a single machine. It doesn't really matter as long as there's some endpoints. This doesn't have to know about real time. It's stateless infrastructure. Now, the demo which I'm going to show you is with Lambda, purely because I can then get to a position where I can build a whole WebSocket system with very, very inexpensively, unless it's used, which on a massive scale, which it becomes more expensive. But I saw this demo of this particular service and thought it was really interesting. And the way it works is you create an API Gateway WebSocket endpoint, and basically that will give you a WSS, which is a secure socket, and it will have some unique ID, .execute API, the region that the API has been set up in, amazon.aws.com, and then the stage of the deployment. So you might have a different stage. You might have a production, development. You can have any deployment stage you want for your API. So you get that URL, and then that's the URL that you paste into your applications. That's the applications connect to. Your mobile app, your chat application, your dashboard, your IoT devices connects up to the gateway, and a physical WebSocket is established, and they are communicating with the server. Now, when we looked at the protocol for WebSockets, you'll notice that messages were passed to the WebSocket. When that happens, messages are passed via a WebSocket between these two parties. When this receives a message, instead of responding itself, what it does is it proxies it to somewhere else. And it proxies it, in this instance, to a Lambda function, along with a connection ID. So it gives it a unique ID for the caller. Whoever called it has a unique connection ID, and it calls the Lambda function with a connection ID. And then that Lambda function then basically knows I've got a person or an individual that I've got an ID for. I store, in my application, I store that in a DynamoDB table. So I store anyone which calls one of these functions, I call the connection ID. So now I have a list of all my connections IDs in a table, in a data store. Well, that's one-way connection, so that's the WebSocket connecting to my application. But and so if a client application sends a message, these messages in a WebSocket are called frames, so you might have multiple frames. If there's 3 messages sent back and forth, it will invoke 3 connections to our stateless infrastructure, our Lambda functions. It invokes the Lambda function. Now, if the Lambda function wants to call the client, well, there's no WebSocket connection between these two things. But what we do have is this connection ID. And what I can then do is, instead of calling back to the client, is I call back into the web API from my function with the connection ID, and I can pass messages. And then the responsibility of this is to get the connection ID and then send the message to the corrected client. So what you end up having is this is stateful WebSocket communications. This is stateless application. This can be an MVC application, it can be Lambda functions, it could be Docker containers, it can be whatever you want it to be. In fact, it could be all of those things. You could have different routes routing to different things. That's the power of the gateway. That's the whole reason why a gateway exists, is it's like a proxy to different pieces of infrastructure. You can even take the message which is coming in and like work on it. So if it was like JSON coming in, you want to convert it to XML to call a specific old API and then get the response back and then convert the response and pass that back in a different way. You could absolutely do that sort of stuff. So that's what the API gateway does. And now it has this new capability of sort of holding these stateful connections. Now the way that a Lambda function actually calls the client is it constructs a thing called a connection URL. Similar to the WebSocket URL, but it's just a REST call that it makes to execute API, region, environment, the connection ID, so the ID that you have, the connections, and then the connection ID, and then you can just post to that URL, and it will then ultimately send a message back to that particular user. That REST API, which you can call, if you have 10 people connected to your service, you will have somewhere in memory, in cache, in store, you'll have 10 connection IDs. If you wanted to call all 10 of them, you basically loop through this 10 times with different connection IDs, if that makes sense. You can post a message to them, you can get their current connection status, or you can delete the connection between web API and that client. So it's a REST API. Predominantly, most people are just going to be posting to it, but you can also sort of inspect the connection as well. It's got a mechanism to do that.
Sorry, I've got a question here.
Yep.
So one of those connections is me. Assume I'm trying to be a very bad user, and just bombarding the man in the middle or the API with too many requests.
Yep.
And then assume I've stacked up 10,000 requests.
Yep.
And then each of those requests is being served by the Lambda function.
Yep.
How would you say it was at the gateway level? You can say stop dealing with this guy.
Yep.
Just bar this guy. But how would you do that from the Lambda function if you bypass the gateway?
So the Lambda function, when it's calling back, so your requests, that would be absorbed by the API gateway service, and there'd be stuff that you could do to basically you could stop malicious stuff at the gateway level. It wouldn't actually end up into the service to then be called back. So you would basically could have logic in your system say don't send more than 20,000 messages from my application if that scenario arose. But they don't actually have any way of physically invoking your Lambda function other than through the gateway. So they have to come through the gateway, and in the gateway you can manage malicious behavior.
The scenario I was trying to make is if I sent say 1,000 connections in 1 minute.
Yep.
So each of those 1,000 connections, or at least 100, make it through. So is it the case that 100 would be served?
Yes, they potentially would be served. Yeah, okay. But I mean, you could have protection layers all the way through that. Okay. One, you could restrict or throttle based upon the connection. You could authorize. There's loads of different ways that you could do you could deal with that. And in fact, that's one of the benefits. If that happened on a Signal R system and you just call that, you basically DDoS that endpoint, you would eventually bring down the service. I don't think you're going to bring down this service as easily because it's obviously we have very large customers using this service, so it's much more resilient. And that's part of the reason why you might use a service like this is because the resiliency that's baked into it. We have a service level agreement to how many transactions you can do, and you can up those different transactions. And and I forget off the top of my head how many transactions it is per second, but it's a lot. And it's also, we have a scalability ability to scale it. So we end up with an architecture which ends up, in a real-time chat scenario, ends up like this. I have 3 Lambda functions. One called onConnect, one called sendMessage, one called onDisconnect. I've got a DynamoDB in the background, which is where I'm storing arbitrarily my connection IDs. That could be, doesn't have to be DynamoDB. It could be anything. And then API Gateway will basically route a message to the different Lambda function based upon a thing called the action header. So when I send a request in from my application, I'll send in a message header which just says route this particular message to one of these 3 Lambda functions. If it goes to the send message function is going to have some logic in there which is basically going to send messages to the whole room, the whole chat room. The onConnect function, all that does is it accepts a connection, it takes your connection ID and it stores it in the DynamoDB. That's called once when the application is started. It assigns you a connection ID and then it calls the onConnect function, and then that stats up the DynamoDB, it adds it to the DynamoDB table. The send message function basically takes the message, and it takes that message then loops through all of the connections and sends them all a message. And we have an onDisconnect function, which is someone disconnects their WebSocket, it sends us a function so that we can remove them from the database, their connection ID from the database. So the actual message, once the WebSocket's connected, the message we pass looks a bit like this. We have a message, actually I think in my API I call this action, but message, the route that it needs to be sent to. In this instance, it's a send message route. And then we have some data, hello Reading, which is what we're going to be passing through. So to show you this, mirror displays, I've built another little application which might go wrong, we'll see. And hopefully it's updated. Actually, I've just realized it might not have. So hopefully this should be hosted on a thing called chat.thebeebs.net. If you're on chat.thebeebs.net, if you've got a URL, if you've got a mobile phone and you go to the URL chat.thebeebs.net, chat.thebeebs.net, and you'll have to press the connect button. I actually, in a regular application, we wouldn't allow users to enter their own WebSocket connection. I'm just added it there because it's quite useful for if you ever wanted to test your own WebSocket to see if it was working, you could use this little application. Oh, so we've got a few people. Hello Reading, Ninja. Always gets a little bit worrying that someone might swear. Please don't swear. Oh, Skimmer Chef is amazing in open source. I wonder who that could have come from. Yeah, Inception for the win, blah, blah, blah. It's cool, right? So, and obviously if I send a message, boom, it will pop up on there, yeah? So this is set up in that way. And I'll just show you a little bit about, well, what is it made up of? So the chat application, it's on my GitHub, it's called WebSockets Chat Application. If you're interested to build this in JavaScript, actually, I've got a thing there, realtime.thebeebs.net, which is actually a tutorial about how you would build this whole thing. I'm writing a .NET version for at the moment as well. And we've got this chat application, which is this is a Vue application. I'll zoom in a moment if I find anything I need to log on to. There's nothing particularly that interesting in the HTML other than that it's a Vue template, a Vue.js template. And in the JavaScript section, you'll see that I've got this socket address that I've pre-pidded in my application. You can actually change it as you saw, but that's the socket address that it's going to connect up to. And that's basically the API that I set up. And we've got a connect function. So socket, I create a new WebSocket. So this is basically a JavaScript object. This is any browser you have a WebSocket connection. In C#, there's a WebSocket object you can create. You pass it an address. When it opens, I'll change the connection to connected. And when any message comes out, it basically takes that message and it pushes it to our list of messages in our application. I've got a disconnect function, so when the socket gets closed, and I've got a send message function. So when you type something in, you press send, it calls the send message function, and this just creates a message with the send message as the root, and then some data. And then it sends it via the socket, and then it pushes that message to the chat, and that's how it works. So the JavaScript behind this is tiny. I've called it actually calls three different WebSockets functions there. And what it's calling in the background is this API gateway. So this is a simple WebSocket. This is what API gateway looks like. If I wanted to create a new API, I would go in here and I'd say create API. And I can create a WebSocket or a REST API. Obviously, I'm creating a WebSocket API, but the original API gateway, what it did, it's a gateway for like managing REST applications. You can basically get 4 or 5 different applications and consolidate the API using API gateway, and then you can send to different systems. That's the whole point of what API gateway does. And it supports things like Swagger and OpenAPI and things like that to create the APIs. Now, if I were to just create a WebSockets thing, I give my WebSocket name a name, and then I give this thing called a root selection expression. And the root selection expression is basically what I use to determine which route it should go to. Send message, on connect, or disconnect. So if we look back at the APIs that I've got, if I look at this simple web application one, I've got that request body message is my root expression. I've got connect, disconnect, send message. And what happens is send message comes in. I don't do anything with the incoming request, and then I pass it to a thing called a Lambda function. A Lambda function is a C# or a .NET or a PHP or a Go or a COBOL function, whatever language you choose. You could be the back end for that. And it calls that Lambda function and gets a response back. Now, my Lambda functions have some logic in them, obviously. And I'll just show you quickly what that looks like. Sorry, too many windows open. Functions. So we have onConnect function. I'll describe what the onConnection function does because there's quite a lot of code. Well, there's a bit of code which comes in. Basically, onConnection takes the ID of the connection ID here, and it stores it in a table, and then it returns 200 OK, and that's it. That's all the onConnect function does. It stores the connection ID into a table. The onDisconnect, all that does is it. Let's see what it does. It takes the connection ID and it deletes it from a table. So those two functions, all they do is someone connects or someone disconnects, it removes or adds their connection ID from my DynamoDB table, my database. And then send message is the only other function. Send message, it does a scan of the table. Basically, that's like a query on the DynamoDB table. Gets all the connection IDs, and then somewhere down here, it will loop through them for each connection ID, and it's going to post the message which someone sent to all of the connections. So basically, everyone's going to get that message broadcast to them. So this is a very simple, classic chat application. But what we've done is we've taken something which was very difficult to scale. And by using this web API, we've taken all of the complexity of dealing with the scaling, at least, of a WebSockets and kind of put it into this service and dealt with it in that service. These are Lambda functions, by the way. I don't know if you've seen Lambda functions before. Lambda functions are relatively easy to write. I can do it like blindfolded like this. Look. I can't really do this. There's a whole trick. If anyone wants to know that trick, I really want some help on a project. This is a side note. What I just did there was pretended that I was typing really, really fast. And I've got a feeling I'm wanting to develop this tool that I've just developed here It's actually hosted on our website called hack.thebeebs.net. And I'm using the most unused feature of Visual Studio, which is the web browser, to go to hack.thebeebs. And then as you type, it like writes a Lambda function. And I've done that on stage quite a few times, a little bit more convincingly, and built up the speed. And people are like, oh my God, he can type fast. But it's a GitHub project that I've built. It's built on the Monaco editor, which Microsoft released and open sourced, as an integration to Visual Studio. And I think it would be awesome to create a live coding. There's an opportunity to create a live coding system for on-stage stuff. If you're interested at all in working on that with me, if you've got some JavaScript skills, then please do contact me, because I'm looking at building that and making it into a bigger project and also creating it in Visual Studio Code. But that's functionally a function in C# in Lambda. So you basically write your code. All this function does is take an input and to uppers it, converts it to uppercase, and then responds back. And what's cool about serverless functions like this, it's true of Lambda, it's true of Azure functions, is that you only pay for the execution of that function. So basically our application is a static JavaScript application in Vue.js. On AWS that costs pennies to host for a month, and with massive scale, with HTTPS certificates and domains and custom domains, I can host that for literally under $1 a month, but scale it massively. I've got the API gateway, which is, there's a cost to that, and that's basically based upon how many times it's called. And then there's a cost to actually executing the functions, but I only ever pay for what I execute. So what I've created is a completely serverless platform in that I only ever pay if anyone actually uses my application with serverless functions, with those sorts of things. So it's an interesting way of building a real-time application in that if I build it, and for example, I use that application here tonight, and then no one uses it for another month and a half, it's cost me probably less than 10 pence to make that application run. And I don't have to go and redeploy it or bring it down. It will just stay there and stay operating. And if someone goes and uses it, it will work. And I'll pay for whatever usage that they use. And it can scale massively as well, because these are functions and it's a managed socket service. If I have a massive influx of 10,000 users, I know that will be able to handle that amount of users. The architecture. Now, if I'd have built that as virtual machines in SignalR, like I'd have had to pay the virtual machine cost, the SignalR cost, potentially the Redis costs, and I'd only be able to burst to a certain point of actual users. So it's an interesting kind of new architecture for it. Now, I'm kind of running out of time. The thing that I'm going to be showing at NDC is basically that same application, but using, instead of Vue.js, Blazor. And now Blazor is really interesting as a platform. It's written by many people, but Steve Sanderson was the person which created this originally. Now Steve, if you don't know him, is the inventor of Knockout.js, and I think his most honourable thing is if you've ever read Rock's ASP.NET MVC3, he was one of the co-authors, and that's where I became his biggest fan. But Knockout.js was a massive JavaScript framework, single-page application framework. He basically got this concept of WebAssembly in browsers and realized that he could cross-compile C# down to WebAssembly, and you could effectively execute C# in the browser. So where I was using Vue.js before to do my browser stuff, in the Blazor version of this application, I'm using C#. So I'm not using JavaScript really at all to do any of the client-side application. I'm doing it all in C#. So that means that I'm able to create a static C# application, and once it's built, a Blazor WebAssembly application, once it's built, it's just static HTML. I can host it in S3 or a storage system. It costs nothing to host. And then I can call these connection IDs in the back end to add real-time support to my web application. Again, all serverlessly. So I'm only paying for it if it's actually used. So I won't go into that too much because I've already talked, and I'm basically losing the ability to talk. But that is kind of what Blazor. There's a version which you'll find on GitHub, and you'll be able to find it after my talk tomorrow in NDC, where I basically take that Vue application. So if you're interested in looking at the voting application but built in Blazor, then please do take a look at my GitHub as of tomorrow, and you'll be able to see that there. One other thing, if there is anyone interested in the audience, there is a concept called GraphQL, which I'm really interested in GraphQL. It's massive in the JavaScript community. It's a way of storing data, and it has this ability to not only be like a database schema, but also when something's added to the database or removed from the database, you can subscribe to those events that happen, and your applications can subscribe to things getting added, deleted, or updated. And then you can subscribe inside of applications, and then there's a transport over WebSockets, which is passed back to the application. Now, we have a service called AWS AppSync, and it's basically a managed GraphQL service, and I want to port this to .NET. And I'm looking for people which might want to work on that or be interested in doing it. What's interesting about this is, for some reason, the AppSync people are able to get to like a million transactions per second on their WebSocket connections. So it actually is able to handle bigger load than the other scenario that I just showed you. So I'm really interested in GraphQL. I don't have anything to demo this or show this at the moment, and I've run out of time to go through exactly what it is. But if anyone is interested at all in getting involved in a very fledgling .NET open source project and are interested in GraphQL, then please do come speak to me, because I'd love to build this out a little bit more. And with that, I just kind of talk a little bit about what we did. I showed you what real-time was. I showed you what Signal R is and the state of how you build applications in .NET today. I then showed you a new method for building real-time applications using API Gateway and WebSockets. I briefly touched on Blazor, and we'll share a project which actually implements Blazor and API Gateway and WebSockets as of Thursday. And then talked about an open source project I want to work on with real-time and AppSync. And that is me done talking. Thank you very much. I'm Martin Beeby, @the Beebs on Twitter.